almost did take like weeks from like school, like show people how like actually like crazy I am like high school. I was nuts. I was nuts, dude.
All right, so let's get started with the rest of this lecture. Use partial fractions to evaluate the integral. I'll have it posted this after class.
We have to set up our test.
Oh, that's right. Thank you for reminding me. With this problem. So we're using partial fractions to evaluate this. Now, the first thing you got to do is make sure that your power in the top is 1 degree less than the power in the bottom, which it is. That's in factored form. This, yeah, the kind of thing about that, yes. It's flip-flop. We want it to, it was, oblique is, the top has to be bigger. This, the bottom has to be bigger. Okay, so now we're going to split it up. We're going to do 6x, or you're not writing, 6x plus 7 over x plus 2 squared. Now, because it's squared, we have to do every power below it. So we're going to do a over x plus 2 plus b over x plus 2 squared. And so if it had been x cubed, we would have said a over x plus 2, b over x plus 2 squared, c over x plus 2 cubed. You know, you got to do all the powers below.
Example, general formula for this
That was that back up here. That thing right there. Actually, this is the one right here. See, like that. That's the quadratic one. So if you have quadratic, if you have second degree, the one above it has to be first degree. Notice it's 1 power below.
here we need to also cosine.
See, it's a linear. See, these are linear factors. These are linear factors. So above is constants. These are quadratic factors. So above is linear. Now, it may not be linear. It may end up being 0, or C may be, you know, one of the x's may end up being 0, but there's a possibility that you have a linear over quadratic. That's a possibility. Oh, okay. Well, you're lucky.
We finished all homework for the day. Yes.
Good. All right, so let's finish this out.
So if it wasn't
Not necessarily got to look at the review. Here are the fractions.
As long as we know.
Don't look for the shortcuts. So we're going to multiply through by x plus 2 times x plus 2. So those cancel. One of those cancel, and both of those cancel. So I have 6x plus 7 equals a times x plus 2 plus b. So 6x plus 7 equals ax plus 2a plus b. So coefficients of x, 6 equals a. Coefficients of x to the 0,
like grouped together.
Oh, equals. Oh, like up here?
Yeah.
Okay.
So it's like similar.
Okay. The pen is not working today.
It's not equal to 2A plus.
No, it's equal to 2A plus B.
Exact same equations. 7 is in the same spot as 2A plus B.
Oh, absolutely.
Yeah, that's why he going to.
All right, so we already have A is 6. So we just use substitution. 7 equals 2 times 6 plus B. 7 equals 12 plus B. Negative 5 equals B. Okay, so what we have is we have the integral of 6x plus 7 over x plus 2 squared dx equals the integral of 6 over x plus 2 plus minus, well, we're just going to say plus negative 5 over x plus 2 squared dx. So all that work was just to set it up so that we could integrate it. So what we're doing is we're breaking the fractions apart into two different fractions. So now we're going to integrate this. Oops.
The
6,
previous part is just
6 integral 1 over x plus 2 minus 5 integral 1 over x plus 2 squared dx. We're going to let u equal x plus 2 and du equals dx. So 6 integral 1 over u du, oops, I forgot my dx, minus 5 integral u to the negative 2 du. So that's 6 ln of u minus 5 u to the negative 1 over negative 1 plus c.
Why didn't you change the 1 over u?
Because you got to add 1 when you integrate. Oh, because 1 over u is ln, but u to the negative 2 doesn't have an ln in it. We have to do, or u to the second, 1 over u squared is not an ln problem. Say it right.
So,
So this is 6 ln of x plus 2. So that's plus 5 times 1 over x plus 2 plus c. That's it. It's getting the magic from the original problem to the partial fractions. That's the thing.
that was understood.
it's like a college algebra. Keep in mind,
It's
he
like-
wasn't here yesterday.
Yeah, you're
I understand.
good. Use partial fractions. To evaluate the integral of 2x cubed minus 4x squared minus x minus 3 over x squared minus 2x minus 3 dx. Okay, so notice that this is an improper fraction. The top of the fraction has a degree higher than the bottom of the fraction. So what we have to do is we have to use long division. Use long division to make a proper fraction.
terms. When did you learn?
We learned it in intermediate algebra. We didn't cover it in college algebra and pre-cal.
What's-
What'd you have for pre-cal?
Go right now.
Oh, you're doing the long division. Yeah, you're doing the online. Okay, so 3 terms on the outside, 3 terms on the inside. We're going to write our answer above the third term. We're comparing x squared to 2x cubed. What do I multiply x squared by to get 2x cubed? 2x. 2x times x squared is 2x cubed. 2x times negative 2x is negative 4x squared. 2x times negative 3 is negative 6x. If that's because when you divide 27 into 934, don't you write 4 right there above the second number? That's the way you're supposed to do it.
Yeah.
You put it over the last digit you're going to use. Place value.
It's not 4.
It's all about place value.
It's 3.
Never
Oh,
got
that's
taught
what they
that.
got from-
I never got taught that. I just knew.
But the whole idea is lining up place value. If you'll notice, the x is above my x. Yeah.
And X squared.
Right.
That's just to make it.
Right. Now, some videos, they started above the first number, which doesn't make sense to me because they're not alike. You know, you're supposed to be lining up like things. Okay, so this is what I did. I did 2x times x squared minus 2x. So that's where I get the 2x cubed minus 4x squared minus 6x. That's where I got that from. In case you didn't follow me multiplying.
Oh. So where is this? 3 here.
No. That 3 is this 3. And this,
Who's that?
that, and I put it. And so now we're subtracting, right? When you do long division, you subtract. So when you draw your line, you're going to change your signs. Because that's subtraction. That'll work. That cancels. That cancels. And I get 5x. And I bring down my 3. And then there's nothing because I don't have any x squared terms. So 0 plus 0. Change my signs. 5x minus 3 plus 5x minus 3 over x squared minus 2x minus 3. So
It's 2X.
we went from the integral of 2x cubed minus 4x squared minus x minus 3 over x squared minus 2x minus 3 dx to the integral of 2x plus 5x minus 3 over x squared minus 2x minus 3 dx. So that's what we've just done. Okay, and we can separate those, right?
So I
You got to learn long division. You can't do it without learning long division.
do research.
Yep.
It's just like division with regular.
Yep.
Yeah. Like long division with regular numbers.
You never done.
No, I have a regular number, but not have
With poly. Yeah.
They're very simple.
Wait, it's literally the same. It's just as long as you know how to subtract and multiply.
Well, people don't like long division to begin with, and then I throw in letters, it freaks them out. Okay, so that is what equal to this. What we're going to do is we're going to stop for a minute and we have to do the conversion of 5x minus 3 over x squared minus 2x minus 3. First off, we got to factor that denominator. Factors of 3 that subtract to give us 2. 1 and 3. And it's a minus 3 and a plus 1. Okay. So now those are linear factors and they're distinct factors. So this, oops, too far. This thing's making me angry. A over x minus 3 plus b over x plus 1. Okay, so we're gonna
leave that 2x dx alone.
leave it alone for right now. Correct. So we're gonna clear our fractions again. We're gonna multiply by x minus 3, x plus 1, x minus 3, x plus 1, x minus 3, x plus 1. All right, so both of those cancel. X minus 3's cancel. X plus 1's cancel. So 5x minus 3 equals a times x plus 1 plus b times x minus 3. 5x minus 3 equals ax plus a plus bx minus 3b. So all I did was just distribute the LCD through, cancel what I could cancel, and now I'm distributing through the parentheses, and now I'm going to group.
So basically, you said about this common cancel them out, multiply the a's and the b's through.
Right. And now we're going to group the x terms together and the non-x terms together. A plus bx plus a minus 3b. Like that?
So now 5x.
Wait, we got to do our coefficient. Well, you're doing it, but you don't put the x. It's coefficient of x.
5 equal to 8.
5 equals a plus b.
Oh,
Equal.
This is magic.
Yeah, there's multiple ways. Yeah, you can do substitution or elimination. This was, since it's a plus b, it's pretty easy to do substitution, but you can do elimination. It comes out to the same answer. We're going to do a plus b equals 5. That's a b. And so b equals a 5 minus a. Okay, so now we're gonna I'm ignoring now. I'm gonna substitute that in for the b in the other equation. So -3 equals a minus 3 times 5 minus a. So notice it's all a terms, minus 15 plus 3a. -3 equals 4a minus 15. Add 15. 12 equals 4a. So a equals 3.
So all that is of that line coefficient x.
Right here?
And that all that is you're getting the a's and b's, setting them up to where they match the only.
Right. So now I'm going to take that 3 and go back and plug it in. So b equals 5 minus 3. So b equals 2. So now I can go back to my problem. The integral of 2x dx plus the integral of 3 over x, what did I say? Minus 3 plus 2 over x plus 1 dx. Okay, so let's go ahead and split it one more time and then I'll do the integration. Plus 3 integral 1 over x minus 3 dx plus 2 integral 1 over x plus 1 dx.
What's the plus 3 come?
The 3 in the top, which was a, okay, so this is going to be 2 x squared over 2. So just x squared, and 3 ln of x minus 3 plus 2 ln plus 1 plus c. And that's the answer. Nope, only the ones where the top is bigger than the bottom.
This is only one.
Yeah, well, this is substitution. I could have said, okay, I'm gonna multiply the bottom equation by -1 and add the two equations together, and I would have had 8 equals 4b, which is 2, and then go back and plug 2 in. 2 plus what equals 5? 2 plus 3 equals 5. So you could use elimination or substitution. Ooh. All right, everybody caught up with me? Well, everybody's hands are like, wait, shake it off before she makes me write some more. All right. Use partial fractions to evaluate. Integral of -2x plus 4 over x squared plus 1 x minus 1 squared dx. Okay, so the top is linear, and the bottom is 4th degree. Okay, so that's good. We don't have to do any division. Plus, they've already factored the denominator for me. I have a quadratic factor and 2 linear factors. So let's do our partial fractions. -2x plus 4 over x squared plus 1 x minus 1 squared. That's going to be ax plus b over x squared plus 1 because that's a quadratic, and we have to have the linear factor above because it might be. It may not be, it may be. Okay, well, you lucked out. The b must have been a 0.
Square plus 1.
But what I'm saying is, if the b part of mine must have been a 0 on yours for it to
Oh,
work.
you know what? It's because there was a difference of squares.
Oh.
Yeah, so while it looks the same, it's not.
Right. This one is an irreducible quadratic, so I can't break it down.
So that's why you need the.
Right. So d over x minus 1 squared. Okay, so we're going to clear our fractions. He was saying that he had x squared minus 1 instead of plus 1, so he put a over his.
It makes it look very
It made it look very different.
because x squared minus 1.
Yeah, where this one you can't do. All right, so
But why is that? Why is it?
because if you have an irreducible quadratic, there's a possibility of a linear factor above. So you have to do the ax plus b. And now it may be that the a goes to 0 and just leaves a b, a constant on top. We don't know. But there is a possibility that the top could be a linear factor. All right, so multiply by our LCD, x squared plus 1, x minus 1, x minus 1, x squared plus 1, x minus 1, x minus 1, x squared plus 1, x minus 1.
The degree has to match the number.
Right.
And so you have to have D. So if you get the
Okay. Minus 1, minus 1. All right, so let's see, cancel. That cancels with that. That cancels with that. That cancels with that. That cancels with that. So I have negative 2x plus 4 equals ax plus b times x minus 1 times x minus 1 plus c times x squared plus 1 x minus 1 plus d times x squared plus 1.
It's probably better to write
Well, we're going to have to FOIL it, so. Yeah, we got to multiply it all out. All right, so negative 2x plus 4 equals ax plus b times x squared minus 2x plus 1. FOIL, yeah.
FOIL x minus 1.
You sure that's not plus 2x minus 1?
Nope.
FOIL again.
Right. So FOIL it, you got first times first, x cubed, outers is negative x squared, inners is positive x, last times last is negative 1. All right. So now I still have to multiply again. So ax times x squared is ax cubed minus 2ax squared plus ax plus bx squared minus 2bx plus b plus c x cubed minus c x squared plus cx minus c plus dx squared plus d. All right.
We should get these done for you.
Yeah, they wouldn't be able to do that. All right, so a, yes, sir, plus c x cubed
Yes, A plus C.
a and cx cubed. And then I've got negative,
Oh, you grew.
yeah,
Q,
negative
X
2x squared, bx squared, cx squared, d squared. Plus c plus a minus 2b plus c. A minus 2b plus c x plus
B minus C
plus.
plus D.
Did I miss something? And the x squared, yes, it's minus c. All right, so A minus 2A, B minus 2B, B, C minus C, C minus C, D, D. All right, now coefficients.
No, but then in the left part, there is no x cube and the x squared.
So what number represents none?
Zero?
0
Oh, really?
equals A plus C. Coefficient of x squared and then coefficients of x equals A minus 2B plus C.
4 equal to b minus c plus.
4 equals B minus C plus D. All right, so from here, we get A equals negative C. All right, so looking at that, I'm going to label these equation 1, 2, 3, 4. Okay, so I can write what I'm going to do. Okay,
Here, here.
not yet. Look at 2 and 4. Okay, we're going to subtract. Yes, that's true. We're going to get to that in a minute. Subtract equation 2 from equation 4 because they have the most letters in it.
That's literally. Equation 2 is negative 2A.
Oh, I learned that. This
Minus C plus D equals. Put that in equation.
So I said subtract. That means we'll change the sign. See? And so I get negative 4 equals negative 2A.
2.
So 2 equals A. And from that, we know that
C is also.
C, 2 equals negative C, so negative 2 equals C.
This is the stuff.
This is 2. This is, now I need to find B. And let's go to equation 3 because it's got A and C and B, and I need B and I need D. Okay?
Well, A and C equals 0.
I've used up this one. Yes. Okay, but look, A plus C, I've used it up. I can't use it anymore. If I look at the second equation, like I've got A and I've got C, so there's nothing else to do to it. In 2, I have A and I have C, but I need B and D. I need 2 letters. In 3, I have A and I have C and I need B and there's only 1 letter. So I'm going to go to equation 2, 3.
Can you plug in this guy to this guy and then you can finally.
No.
You
I
cannot
can
do
do,
that?
I can't do 4, but I can do 3. Because it's A and C, not B and C.
Oh, A and C. Oh, yeah.
So I gotta go equation, plug in A and C to equation 3. So negative 2 equals 2 minus 2B minus 2. So negative 2 equals negative 2B. Divide by negative 2, you get 1 equals B. So I've used ABC, got that done. Now I can go into equation 3 or 4. 4 is easier, So we're gonna go plug into equation 4.
So that minus C to that -2. Right here.
Yes.
Yeah, yes.
That's the stuff.
Plug into equation 4. 4 equals B minus C plus D. 4 equals 1 plus 2 plus D. 4
So,
equals 3 plus
C
D
equal to 1.
equals D.
So now you're just plugging A, B, C, D.
Right. So now we're going to integrate negative 2x plus 4 over x squared plus 1 x minus 1 squared dx equals, I'm going to go ahead and separate them. A is 2x plus 1 over x squared plus 1 dx plus the integral of c, negative 2 over x minus 1 dx plus d, which is 1 over x minus 1 squared dx. Okay,
So we just integrate all that.
integrate all that. So all that work just so we can go and integrate all that.
Which most of those
Right, but what we're going to do is, before we can do anything else, that 2x squared plus 1 over x squared plus 1 is a problem because of the plus 1. So what we're going to do is we're going to pull this apart. Because if I let u equal x squared plus 1, then du is equal to 2x. 2x plus 1. So we're going to write this as the integral of 2x over x squared plus 1 dx. Well, let me put in the extra step. Plus 1 over x squared plus 1 dx. That's a fraction problem. You can break them apart. If they're added or subtracted in the top, you can break them apart. Minus 2 integral 1 over x minus 1 dx plus 1 over x minus 1 squared dx. So break it apart.
just like doing this.
The applications, nobody ever likes to do the applications. Where, okay. This right here. Okay, if I wanted to use u substitution, let u equal x squared plus 1, then du is 2x. But that plus 1 at the top makes that difficult to do. Since this is an addition, I can break it into two fractions, because if I put it back together, it would just be 2x plus 1. So I break it into two fractions and made it into two separate integrations. So now this first one, I can integrate with u substitution, ln, u substitution.
You said ln on the second one.
ln here, because it's 1 over something. Right?
The square doesn't mess it up.
No, I take that back. It's not ln. What is it? Get your papers out.
Sine or cosine? Oh, it's tangent, inverse tangent.
Inverse
There you
tangent,
go.
there you go. Inverse.
I was just studying.
So, U substitution, inverse tangent, ln, U substitution.
It's a common. Inverse. Math is probably.
All right, so let's do our U substitution. U equals x squared plus 1, du equals 2x dx. So this is the integral of 1 over u du plus the integral of 1 over x squared plus 1 dx minus 2 integral 1 over x minus 1 dx. We're going to let u equal x minus 1, and du equals dx. So this will be plus the integral, and that's going to be u to the negative 2 du. So this is ln of u plus tangent inverse of x. And remember, if that had been x squared plus 4, then it would be x over 2. If this had been x squared plus 4, you got to factor out that 4 and be x over 2, just like what we did last time.
That's gonna be important.
He finished tomorrow. No.
He's finished today's homework. 2 ln x minus 1.
It's because I'm slipping up.
Yeah, not have like a an F in
And that's unacceptable.
your. Yeah.
Yeah. So it's 1 squared, so that would be x over 1, which we don't want. Right. It'll be 2 squared, right? All right, but I'm not done because I have x's and u's, and I have to have all x's. So that equals ln of x squared plus 1 plus tangent inverse x minus 2 ln of absolute value of x minus 1 minus x 1 over x minus 1 plus c. Now remember, that c is an arbitrary constant. It's not the c from above.
It wasn't there.
Well, I could probably put the LNs together as division. Yes, you can.
Because the twos are.
You move the 2 over as an exponent of the x minus 1, of the absolute value of the x minus 1, which makes it positive all the way. Yeah. Yeah, we're going to have, no, it's not going to be a 3-hour test, but it's going to be like this last one, no more than 10 questions, because you don't have time.
Why do they do that? The time limit on.
Just because you have to be a time limit. If it was in class, you'd only have 75 minutes. Yeah, it's just administrative issues.
So it's like, well, we're like, this is gonna be our life, but we're gonna have days to be able to work these problems.
So, not necessarily. You know, when the shuttle's coming in and it's got problems, you got to fix that problem right
Well, I'm talking about like with civil engineering, you have days.
there.
Road construction, they take forever.
Oh, you just need to drive between Hammond and Baton Rouge. They finally decided to put out a 3rd lane out there. I lived in Lafayette for 11 years. I never drove home that there wasn't construction on
It's the same
10 or
story with
12.
Jackson. find out.
Is inverse tangent of x equal
Inverse tangent, no, that means that tangent inverse x equals something. So x equals tangent of that something.
Who's that?
That's what that
So
means.
how would you determine what we had?
We're integrating. All that was just to integrate. And it makes, see, we can integrate these little pieces, but we couldn't necessarily integrate that big piece. We don't really know how to integrate that piece with what we have. No, yeah, the area under the curve, yes, that's helping us find the area under the curve. So you give me some numbers and I can plug in those numbers for X. My lower limit, my upper limit, I can plug those numbers in for X and I can find the area under that curve in that region. But this is arbitrary, so this is just a formula to find the area. All right, so let me erase that. Did you understand what I said? Yes.
Yeah,
Okay.
I just wrote it down wrong. I had the right thing.
Okay.
What would you say here? If
Are you one being that?
if one is not one, what was the?
It would be, if one was 4,
Uh-huh.
then it would be X over 2. Over 2,
Over two.
yes.
Did you write? Color? Oh, two inside, right?
Yeah,
Parentheses.
in the parentheses, you would put,
What about one is not one?
then you gotta have to, if it's a number, you just pull it out in front. No, we have credit behind our currency. Yeah,
US dollars.
yep.
I need gold. More expensive. Like 1 gram.
All right, so back up here. So the first thing we gotta do is convert. Okay, so what do I need to do first? Well, I can't factor x squared plus 1, it's not factorable. Okay, so what do I put under the first line? And then under the second line. Okay, and so that means I need, so what goes above x? What goes above x squared plus 1? X plus c.
So you find this out by adding like the linear thing out of that.
Yes,
Okay, so if it's squared, you would do it.
right. Okay,
Degree 5.
so now we got to get rid of our fractions, clear our fractions. X times x squared plus 1, x squared plus 1, x times x squared plus 1, x squared plus 1, x times x squared plus 1, x squared plus 1, x times x squared plus 1, x squared plus 1.
Because it's new.
What?
Formula. I think
Oh, x squared plus 1 factors into x plus I, x minus I. You can't have i's. Not here. Okay, so all that cancels. Oops, change my color. All that cancels. Just the x cancels. Just one of those cancel and two of those cancel. So 1 equals a times x squared plus 1, x squared plus 1. Julie, will you shut the door, please? Dx plus c. X squared plus 1 plus x times
I was.
dx. That's because you're friends with it. Or friendly with it. Okay, so now then, gotta multiply all this out.
There, now, I noticed, I'm like a shortcut, but is there almost a quicker way to do the step we just did? Like, I understand how to do it, but like, is there like a,
Well, just you look at what's in your denominator and use what I did when I worked this problem.
You multiply by the stuff you don't
All right. See, this is my denominator. I have this, I need these two. Boom. I have one of these, so I need these two. These two, and I need that. So I just multiply.
okay, so you look at it.
So I look at it and go, what do I don't have? That's what I'm multiplying by. Then you just have to work it out. Now, this is going to be, this was a quick multiplication because it's a perfect square trinomial. X to the fourth plus 2x squared plus 1. You can't factor it, you can multiply it. And we don't want to multiply it to start with because we want it in factored form. In the beginning, we want it in factored form. Now we got to multiply. Do what? No, I just multiplied the x squared plus 1 times the x squared plus 1. Yeah, I like to hold anything that's a constant that's out in front. I hold it and do this distribution, then FOIL. You could have said a times x squared plus a times 1 and then FOIL that. But I know, the reason why is I know x squared plus 1 times x squared plus 1 is x to the fourth plus 2x squared plus 1. I knew that. So it's easier to multiply that first for me. Okay. And again, the second thing here, I've distributed the x to the parentheses because that's easier for me to do. We didn't have a plain x last time. Well, but see, again, previously, I did this multiplication first and then distributed the letters through after I multiplied the polynomials I knew. Right, I haven't finished yet. All right. Plus dx squared plus ex. So now I'm going to distribute. 1 equals a x to the fourth plus 2a x squared plus a plus b x to the fourth plus b x squared plus c x to the third plus cx plus dx squared plus dx. So what I did is I said bx times x cubed, dx times x, dx, c times x cubed, c times x.
These are the hard ones.
Yeah.
It's hard one. It's not hard one.
It's all algebra.
It's not hard at all, but you just,
Tedious.
the annoyance of having to do it.
Yeah, the tediousness of it.
That's why I asked.
All right, so now let me group everything. 1 equals a plus b x to the fourth. So mark those off. I need x cubes.
So that all equals 1.
It all equals 1. C
Oh, really? Right.
x
No,
cubed.
equal 0.
All right,
Equals 0?
Yeah.
yes,
Right down, but I mean, I think one was the top.
2a plus, yeah, 1 was the top of the thing. 2a plus b plus d. 2a plus b plus d. X squared, sorry, plus c plus e x huh? Okay, that's fine. A, is it just A? Is there no other constant? Let's A. All right. Coefficient x to the 4th, 0 equals A plus B. Coefficient of x cubed, 0 equals C.
Oh, now we got C.
Yep, so now we got C. My constant,
Because mine doesn't have a-
0 equals 2A plus B plus D. This is 0 power, yeah. 0 equals C plus E. So what does that tell you about E?
Equal 0.
And then X sub 0. 1 equals
A.
A.
Should value true.
Yep.
It's like the same identity.
Yeah. Yeah.
You got 0 x 4. 7 0 x.
So you plug one into the.
Yeah, because you can write this,
Oh, man, that'd be it.
you can write
So
this
P1
over here is 0x to the 4th plus 0x cubed plus 0x squared plus 0x plus
Yeah,
1.
would be negative.
And it's still just be
Yeah,
1.
right, right.
All right, hold on, slow down, slow down, slow down. All right, so from C plus E equals 0, we get E equals 0. Okay, so we have A, C, and E. So now we've got to find B. Okay, this is 1, 2, 3, 4, 5. We've used up this one, and this one. So the next one we want to go to is equation 1. Plug in 0 equals 1 plus B. So B equals -1. So we're finished with equation 1. Now we're going to use equation 3. Plug into equation 3. 0 equals 2 times 1 plus -1 plus D. Okay, so 0 equals 2 minus 1 plus D. 0 equals 1 plus D.
Yeah, and I have a bad problem with that, but I will watch you doing this kid in class and you teaching it one way.
Mhm.
And then when I go to home, I like miss one step, I'll be like, I won't go to like your watch, which I need to.
Mhm.
I'll do just like, hey, give an example, and then I'll get.
Confused. Because they'll do it, because there's many different ways to go about it. Roll up.
It's you we teach them like this way. If oh, don't tell us. It's the way you use teacher and the way you teach.
It's like, one thing you could try is you could try to cancel out some of those,
Yeah, you can plug in 0,
but then 0 just cancels
everything, yeah. No, not necessarily, because if you plug in 0, you get an E.
You have it.
Oh, you get 0 times it, yeah.
But if you get 0, you can find it.
Yeah.
plug in 0.
Right. That's the only thing. A is 1. And then you could probably plug in like 1 and -1. That might help some, but. All right, so now what we have is we have the integral of 1 over x times x squared plus 1 squared dx equals 1 over x plus -1x plus 0 over x squared plus 1 plus -1x plus 0 over x squared plus 1 squared dx.
Just get work. Work.
Final, yeah.
Test 3.
Test 3 won't have work on it. Final. Won't have center mass. Center mass is not gonna be in any of your tests,
Not even the final.
not even the final, because I did, at least, let me clarify, make sure that it's not an SLO. Because if it's not an SLO, it's not gonna be on there. Well, good.
We don't have any center mass.
I have to double check, make sure that it's not a requirement. If it's a requirement, I have to put it on there, and we'll talk about it
I've
again.
been
Center mass and work or something.
Right. I mean, it's part of the curriculum, but it's not necessarily one of the SLOs. So if it's not the SLO, then I don't have to cover it. Student, we're gonna, review for the final, and talk about the final, what you need to make on the final to get whatever grade you want. We're gonna play the what if game.
How do you know this part to this part? We give you the original question.
This is, what was given to us, and we did A plus B, X
So
plus C.
you ignore the part, right?
No, what I did is I plugged in the numbers. See,
Oh, yes, it's from previous. Oh, yeah, that
Right
one.
here. Right there. I plugged in the numbers. Right. So now let's integrate. 1 over X, well, let me separate them. I hate when it does that. All right, so this is the integral of 1 over X dx minus the integral of X over X squared plus 1 dx minus the integral of X over X squared plus 1 squared dx. All right, we're going to let u equal X squared plus 1, then du equals 2x dx, right? So I need to divide by 2. So this is the integral of 1 over x dx minus the integral of 1 over u du over 2 minus the integral of 1 over u squared du over 2.
Let -1 times of x, I make that x. Oh, you guys see.
Hold that for us. Okay, so that's the integral of 1 over x dx minus,
You become ln.
yep, 1 over u du minus 1/2 integral of u to the -2 du. So that's going to equal ln of x minus 1/2 ln of u minus 1/2 u to the -1 over -1 plus c. Now plug in u. ln of x minus 1/2 ln of x squared plus 1 plus, because the two minuses, 1/2 1 over x squared plus 1 plus c. And to clean up a little bit more, you could put, erase that one right there. And make it all one fraction.
It look better.
looks a little better, not much.
Really?
Yeah, because you only got one numerator. Well, we got 4 more minutes of class.
We should get going. So we should be
What presentation?
Well, I don't have time to do a whole. All right, no. Number 7 on the homework is supposed to be hard.
Oh, yeah, he told me. Will you make
Alright.
a video of that?
No, I'm not gonna make a video. I'm going to give you a little, I got 4 minutes. I'll do a little what you need to do.
It's the difference.
All right, so this is gonna be 25 over x plus 1, x minus 1 squared dx, which is 25 over x plus 1 squared, x minus 1 squared dx. So 25, all I did was carry the power in. 20, no,
Yeah, what?
I got rid of this square part by factoring. But then I still had this square that I had to put on it.
Oh, you factored it, you didn't.
Yeah, factor. X squared minus 1 times x squared minus 1. But I factored it. So this is x plus 1 squared, x minus 1 squared. Now, this one's going to end up being doing 2 different things to the problem, or at least the way I did it. You got to do a over x plus 1 plus b over x plus 1 squared plus c over x minus 1 plus d over x minus 1 squared. And what I did is I substituted numbers. I plugged in 1 and -1. So let x equal 1 and -1. Why? Why?
Why?
Why? Because it cancels sums out. Because when you do your product across,
Yeah.
you're gonna have a times, and I don't FOIL it. I didn't, for this step, I just did the 25 equals a times x plus 1 times x minus 1 squared plus b times x plus 1, x minus 1, dot, 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 dot. I left it in that form like that. And I plugged in 1, I plugged in -1, and then what we always try to do is 0.
So it would either come out as 0.
Right. Yeah, 0, 2, -2, or 4.
So wait.
Correct.
It doesn't matter. Every time you get like one of these, it turns into the LN.
Nope.
No, that one.
That one
That's the LN and that.
is
is
the
substitution.
use substitution, yeah.
Okay.
Okay, so I did that, and what happens when I did that on this problem, I got B and I got D. I did not get A and C. So then I had to go back and multiply it all out and group the coefficients together like we did in the other one and solve, plugging in the B and the D and solving for the A and the C. Okay, so it's I mean, look, it's a whole, 2 whole pages.
Take a video of you picture.
Yeah, y'all can take a picture of my pages. Yeah. All right,
Is this question?
that page,
Is the
is-
last example?
example 7.
Is the one you haven't covered, right?
That's